All right, today we're practicing lesson 1-4, 4-1, multiply decimals by power of 10. I can find the product of a decimal number and the power of 10. So I like to call this lesson the decimal slide. So it's really easy to multiply numbers by 10, 100 and 1,000. In whole numbers, we annex zeros. In the decimals, we just move the decimal around. So like I said, I like to call it the decimal slide. Let's see how this works. Javier is helping his parents put up posters in their movie theater. Each poster has a thickness of 12 thousandths of an inch. How thick is a stack of 10 posters, 100, and 1,000 posters? So basically, what we need to do here is we need our equation, or what we're trying to solve is we're solving 0.012 times 10, 0.012 times 100, and 0.012 times 1,000. Now, unlike with whole numbers, we do not annex zeros. Let me show you why we don't do that. So if we're going to multiply 12 thousandths by 10, if we just throw a zero on the end of that, we had this to begin with, and we just chucked a zero on the end, they're equal to each other. We have not changed the value of the first factor. Multiplying by 10 is going to actually move our decimal. And when we multiply, we're going to move the decimal, just like with whole numbers. When you multiply whole numbers together, you wind up with a bigger number. So we want to wind up with a bigger number. The decimal is going to go in that direction. So when I'm multiplying by 10, because we have a base 10 number system, I'm going to actually move the decimal just one place value in this direction. So my answer is going to be 0.12. When we multiply by 100, I'm going to move the decimal in two places. So I'm going to wind up with a 1.2. When we multiply by 1,000, I'm moving the decimal three places. So I'm going to wind up with a 12. So that is how we would do that. We will be reviewing that further in the lesson. But whenever you are multiplying by 10, you're going to move over one place. By 100, you're going to move the decimal two places. By 1,000, you're going to move the decimal three places. And that's for multiplying. Let's preview the next chapter. If you divide, you're not going to be making your value bigger. You're going to be making it smaller. So it's the same process. We're just going to move the decimal in the other direction when we divide by 10, 100, and 1,000. For kids that are working on that on First in Math, you can get started on your multiplication of decimals in First in Math. Make sure you're moving ahead out of whole numbers. A bunch of you are ready to do that. So let's take a look at the problem at the bottom. I'm on my tiny little school computer, so I have to scroll down here. How does your answer for 1,000 posters compare to 12 thousandths? So the decimal point has moved how many places? What did we say? Our decimal has moved three places. To the right. Which remember is in that direction. And it's one place for each zero. So when we have 1,000, we move three places. When we have 100, we move two places, and when we move 10, we only move one place. So that's a little review looking at the structure. So as we turn the page, now remember the next page is covered in the video. If you choose to watch the video that comes with Wonders, I keep saying that, with Savvis, you can watch the video. What patterns can help you multiply decimals by powers of 10? So we already looked a little bit at the patterns. So let's see if we can apply it. A baker has a 10-pound bag of pecans and a 100-pound bag of flour. How many cups of each ingredient does the baker have? If they have three and 63 hundredths cups per pound of flour and 4 and 2 tenths cups per pound of pecans, you're going to multiply decimals by whole numbers here. So, I'm on my other computer. As you can see, it is not like the little board. Why am I on my other computer? Because my older computer has decided it doesn't want to work anymore. So here we go. Use patterns to find the products. So when we multiply by 10, remember we're moving the decimal one place value. And they're showing you here the exponential values of 10, 100, and 1,000. That will help remind you how many places you have to move the decimal. Notice that 1,000 has 3 zeros in it, and we call it 10 to the third power. It's a hint we're going to be moving our decimal 3 places. So in the value 3.63, if I move my decimal 3 places, 1, 2, 3, I'm going to need to annex a 0 to take that space up. So my final answer, when I multiply 3.63 times 1,000, my answer is going to be 3,630. Don't forget to annex that 0. If you don't, this is what your number will look like. 3.63 times 1,000 moves our decimal 1, 2, 3. So that would be weird. Have you ever seen a number that looks like this? Then there's a giant space and a decimal. We don't write our numbers like that. It's very confusing. We need to make sure the reader understands that there's something in that space there. So that 3 is a 3,000, not a 300. So it's really important that you annex that 0. Okay. Continue the pattern to find the number of cups for 100, 1,000, or 10,000. So when we're multiplying by 10 to the first power, we move the decimal one place. 10 to the second power moves it 2, 10 to the third power moves it 3, and the same over here. 10 to the first power moves it one place. 10 to the second power moves it 2 places. 10 to the third power moves it 3 places. 10 to the fourth power, we haven't done that yet, you're going to be moving the decimal 4 places. So in that case, for that one, if you're multiplying 4.2 times 4 times 1,000, we're going to be moving the decimal 1, 2, 3 places, and we're going to have to annex 2 zeros for that one to make sure that the reader knows that our final answer is 4,000. It's not 4, 2, giant space, decimal. Remember, we have to put those zeros in there so the reader understands what number value you are trying to represent. So the decimals always are tight up against a numeric value, and that could be a digit, and that includes 0. So make sure you're keeping that in mind. And at the bottom, we're going to fill out the chart here, completing the chart using what we just learned. So 10 to the first power, get rid of that yellow, that's hard to see. 10 to the first power is going to move the decimal one place. So my 1.275 becomes 12.75. 10 to the second power moves my decimal 2 places. So if I move it 2 places, I wind up with 127.5. And then 10 to the third power moves it 3 places. I wind up with the whole number, 1,275. And if you notice in that problem, we didn't have to annex any zeros. Our decimal did not move outside of the digits that we already had. Let's see if that's different on the next one. Move it 1 place, 26.0.14. Move it 2 places, 2601.4. Move it 3 places, 26014. Didn't have to annex any zeros on that one. On the next one, I think we're going to have to annex our zeros. And let me put it up here so you can see it a little bit better. So 4/10 times 10, 4/10 times 100, and 4/10 times 1,000. And remember these exponents, 10 to the third equals 1,000, 10 to the second equals 100, and 10 to the first equals 10. Let's go back and do a little color change here so we can see what I'm going to do. 0.4 times the whole number 10 moves it one place value, so my final answer is just the number 4. 0.4 times 100 is going to move it 2 places, so I'm going to have to annex a 0 there. And 0.4 times 1,000 is going to move that decimal 3 places, so I'm going to have to annex 2 zeros. Because remember, it's originally here. When I move it 3 places, 1, 2, 3, it's going to wind up at the end. So we're going to wind up with 400. Okay. Now, as we move on to the next page and we do a little bit, another example, and then we'll do some guided practice, and then you can go off on your own. And this is important. What we're doing today will help you too with estimation of decimals. So let's see what we have for another example. You can use patterns to multiply by decimals. Multiply 3 and 63/100 by 1, by 0.1, and by 0.01. This lesson is very tricky. So this lesson is actually thrown in your book here. It's not in the video. It's not on the page before. So it's important that you're paying attention here. I'm multiplying my value by something less than 1. So it's like I'm multiplying it by a fraction. So watch what happens here. So 363 times 1, there's no value change. But when I have 3 and 63/100 times 0.1, it's like I'm multiplying it by 1/10. So I'm multiplying it by something that's less than a whole. So in this case, I'm multiplying it by something less than 10. It's 1/10. So my decimal in this case is actually going in the other direction. So I wind up with 0.363. Because this is less than 1, it's 1/10. And remember, we have a base 10 math system. So 1/10 is going to be, I'm going to be moving left one spot. I know that's a little confusing. And the next one is 3.63 times 0.01. So it's like I'm multiplying this by 1/100th. So again, I'm moving it one place for tenths. I'm going to move it 2 places for 100ths. So my final answer for that one is a really small decimal. That was super sneaky that they snuck that in there. And there's a couple problems that show up. I'm going to hop over to them down in the independent practice as well a little bit. They kind of threw that in there. And it's really not covered in the video page at all in the lesson, the video lesson. So you can see there's a video in my YouTube playlist that addresses this. It's very sneaky they threw that in there like that. So let's take a look. How can you use mental math? Because that's what we're doing. We're not really doing any computation. We're just sliding the decimal around. So you're really just using your mental math strategies to solve these. So how can you use mental math? You know that 10 to the third power is going to be 1,000, which moves the decimal 3 places. So using mental math, I know that it's going to go 1, 2, 3. They mean you're not over here like doing this. You don't have to do that. You do not have to do the algorithm right now. We can just slide the decimal around. So, and then the next one, 45.8 times 100th. Remember, if I'm moving it times 1/10, I'm actually going to move the decimal in the opposite direction. If I'm multiplying it by 100th, I move it twice in the opposite direction. So for that one, you're going to wind up with 0.458. So the first one right here, we have 45, and we're moving the decimal 3 places. And then So that will be the first value. And for the second one, we're moving the decimal 2 places. We wind up with 0.458. So the decimal is going to go 2 places in the other direction. Tricky, I know. So for number 2, it's telling me move it 1 place. So how easy is that? Just move it 1 place. So I end up with 0.09. For number 3, this is telling me move it 3 places. So we're going to wind up with 3,100. For number 4, I'm moving it 2 places. So I'm going to have 6.2. And then for number 5, because it's a decimal, I am moving it in the other direction, and I'm going to move it 2 places, and I'm going to need to annex a 0 on this one, because if I don't, if I have 1.24 divided by 100th, here's divided by 10th, divided by 100th, that's how weird my number would look. So I need to make sure I'm annexing a 0 to take up the space that's created when I move the decimal 2 places. Don't forget to do that. So off we are down to the bottom in independent practice. You're going to see, I just want to jump ahead. I know you can do this on your own. You can go in Buddy Work and do this if you want, or the interactive book, or you can use your regular textbook, whatever works best for you. Make sure you do the quick check. But let me just jump down to, here we go, number 8 and number 11 and number 14 and number 15, because that's kind of going in the decimal is moving in the opposite direction, because we're not multiplying it by a whole number, we're multiplying it by a value that's less than a whole. So when we're multiplying it by 100th, it's going to move 2 places in the other direction. When we're multiplying it by 1/10th, we're going to be moving 1 place. So we're going to have 0.502. When we're multiplying by 1/10th, we're moving it 1 place again. And notice how I actually I'm annexing 2 zeros on this one, only because we usually do not write our decimals like this. And you're going to know in middle school and also on Savvis online, they're going to want that 0 marking the one's place between, right next to the decimal. So the reader's very clear that it's not just some random dot that you accidentally put on the page. It really means a decimal point. So, and in number 15, the 100th tells us to move it 2 places. So I wind up with 6.817. So take your time, and I will see you soon. Bye.